Okay, welcome. We're going to walk through an example of how to graphically analyze a position versus time graph. Now in physics classes, you're going to be challenged to study kinematics, laws of motion, and often you're looking at changes in position over time. We're going to plot change in position, or often what we call displacement on the y-axis, time on the x-axis. And let's say for this example, you're just walking some distance in a line. So if you start at time 0 at the 2-meter position mark, that means you're 2 meters from whatever you set as the starting line, and you move from 2 meters up to 4 meters in the first 2 seconds time. At that point, you stay at the 4-meter mark from time 2 to 4 seconds, and at that point you change directions and you walk from the 4-meter mark back to the 0-meter mark over the next 2 seconds. And looking at this graph, you can answer questions about your average velocity in each of these 3 segments, your total distance traveled, your total displacement traveled, or change in position. And we're going to walk through that. So the first thing I want to start with is total distance. If you imagine this is you walking, and as you travel from the 2-meter mark up to the 4-meter mark, you can see you've traveled a change of 2 meters. The next segment, segment 2, you've stayed at the 4-meter mark. You haven't traveled any distance at all. And in the last segment, you can see you changed your position from the 4-meter mark to the 0-meter mark. So you can make the argument that you have traveled 2 meters plus 0 meters plus 4 meters, which is a total of 6 meters. So the question becomes, okay, how is that different from displacement? Well, in physics, you're going to hear quite a bit about this term displacement, which is your change in position and includes direction. So if you imagine the first segment was a change of positive 2 meters, because your end position was at 4, your starting position was at 2, 4 minus 2 is 2 meters. But in your last segment, you didn't move 2 meters in the positive direction, rather you moved 4 meters in the negative direction. So if you imagine the 4-meter change in segment 3 starts at 4 and ends at 0, 0 minus 4 is a change of negative 4 meters for a total displacement or change in position of negative 2 meters over the course of 6 seconds. Now for each segment, you can also think of the slope of the lines as a way to analyze your average velocity, because slope, simply put, is the rise in any segment over the run. And so if you imagine the rise of any segment as the change in the y variable, the run as the change in the x variable, often algebraically you'll have your algebra teachers tell you that's y2 minus y1, that's the rise, x2 minus x1, that's the run, the change in the x variable. You can easily figure out your slopes. And if you look at the first segment, the change is 2 meters in 2 seconds. So you're walking on average 1 meter per second. In the second segment, your rise is 0 meters over 2 seconds. Therefore, you are not moving, standing still. Slope of a horizontal line, if you recall, is always 0. 0 meters per second is your velocity, so you're not moving. And in the last segment, your change in position is negative 4 meters in the negative direction over 2 seconds for an average velocity of negative 2 meters per second. And looking at the slopes of each of these lines, as long as you think of your rise and your run with your units, you're always going to be left with units of meters per second, because you have meters on your y-axis, seconds on your x-axis. Therefore, you're getting your average velocity for each of the 3 segments. We'll come back to a couple practice problems of this later.